Let's get into making factor trees. They're pretty easy to make, and there's only 3 basic rules you got to follow in order to make them. First rule, if the number is prime, you stop the branch. Second rule you follow is if the number is not prime, you keep going with a times table. And the third rule you follow is you never use 1 on a factor tree. So as a quick review, prime numbers are numbers that only have factors of 1 in itself. 2 is an example of a prime number because 1 and 2 are the only numbers that go into it. 6 is not prime because 1 and 6 aren't the only numbers that go into it. There's other numbers that go into that number. So just keep these things in mind as we work through the next examples. Now we're going to make 2 different factor trees for 90. So 90 is not prime, so we need to branch off with a times table. We're just going to say 3 times 30. That gives us 90. 3 is a prime number. That branch will stop. 30 is not prime, so we need a times table for it. We'll just say 5 times 6. Now for this one, 5 is prime. That branch will stop. 6 is not prime, so we'll branch that out with a times table. We'll use 3 times 2. And now we have 3 and 2. Since those are both prime numbers, both of those branches will stop, and we'll have nowhere else to go. Now we have the factor tree done for 90. Now let's make a second factor tree for 90. Once again, 90 is not prime, so we'll need a times table to branch out. We'll just say 9 times 10. Looking at 9, that's not prime, so we need a times table for it. We'll use 3 times 3. 10 is not prime, so we need a times table for that one too. We'll use 2 times 5. For these, since we know 3 is prime, we know 2 is prime, and if 5 is prime, all the branches will stop, and so we'll have nowhere else to go. Now we have a second factor tree for 90. Just keep in mind that for some numbers, there could be many ways to make a factor tree. And you'll know you did your factor tree correctly because all the circled prime numbers should multiply to equal the original number. So looking at our circled prime numbers, 2 times 3 times 3 times 5 is equal to 90. So both trees are correct. Now let's make a factor tree for 17. But we have a problem. The only factors of 17 are 1 and 17. This is a prime number. So therefore the branch is automatically going to stop. And so this makes an important point. The factor tree of a prime number is just itself. And that's it. The factor tree is done. Now that we're done, you can do something more useful with your time, like do some homework. But don't tell your teacher your dog ate your homework. Tell them wild raccoons ate it. Let me know what they say about it. Like and share. Math on the fly. Laters.